So L is equal to 150 millihenry. That's the inductance. And resistance here is 50 ohms. And the voltage source that's connected with it is 50 volt DC. 50 volt DC. So basically we have a circuit like this, a resistance and an inductance, and of course we have a transient situation. So the switch is turned off. So it turned on at t is equal to 0 basically. So it says we need to find the initial rate of change of current. So we know that the voltage difference across an inductance is given by this one, di over dt, L times di over dt. So we need to find the initial rate of change of current. That will be V over L. So V is 50 and then L is 150 millihenry. So 150 times 10 to the power minus 3. So this becomes, once we do this, it becomes 333.3 amps per second. That's the rate of change of current. And then we need to find the final steady state current. The final steady state current, of course, will be, this is V, this is R, and this is L. Initially, an inductance is open circuit when the switch is closed, because inductance doesn't allow to change the current instantaneously through it. So what happens is, initially the current is 0, but eventually inductance becomes a short circuit. So initially it acts as an open circuit, but eventually it becomes a short circuit. So the initial current, of course, the final current, of course, will be when the inductance is basically a short circuit. So final current will be I final or I infinite, let's say I final. That will be, of course, V over R. So that will be 50 over 50. It's just 1 amps. And then finally, we need to find what is the time taken for the current to change from 0 to its final value. So that will be 5 times tau, and tau is the time constant, and time constant for an RL circuit is given by uh, L over R. So again, L is 0.150 Henry, because it's millihenry, and then this is 50. So tau is equal to 0.003 seconds. So of course, the time taken will be 5 times tau. So 5 times 0.003 seconds will be 0.015 seconds. So that is the time taken for the current to reach its steady state value. So basically, initially when the switch is closed, inductance acts as an open circuit basically, and then slowly the current develops. So the current develops like this and exponentially develops like this, and it reaches the final value. The final value is given by V over R, and initial value is 0, and the time it takes to reach the final value is 5 times tau, and that depends. So tau is L L over R. So if L is high, the time taken is more basically, and if L is low, so higher the inductance, the more it restricts the development of current. Uh, it allows the rate of change of current is slower, because if we look at this equation as well, we can see if L is high, then di over dt will be low. So the way the current changes, the rate of change of current is lower. So yeah, that's it. And these are the numerical results of the particular problem.